Okay, we are live. You can start now.
Okay. Thank you so much for organizing this amazing kind of live stream show. So this is Leon, and I'm from my team. Today we are very honored to be here to give you guys a very brief introduce about what we are and what we are doing and what's the tech part about the Idea Zone. So the reason we organize for the Idea Zone is pretty simple. We want to building a FHA infra to like expand the FHA narrative to another level. That's why we want to do that. So nowadays we got so many projects want to involve with the FH technology, no matter for the BDCFI sector, for the AI sector, for the data storage sector, so on and so forth. So that's how we get started. And for the topic of this, I think at Dearson, we also like share very good thing here. We want to build a future of decentralized and secure AI with us, just generally speaking. And we got around 2,000 USD for the price pool. So yeah, that's all about the information. So let's get started. So for the kind of overall presentation, we got two kind of parts. So the first part will myself will do a brief introduction about my network. Then another like co-member of our team, Dennis, will get started to do some tech sharing about our FH technology. So that topic is about fair voting powered by FHE to let you guys know more about the inner, the deep tech behind the products and how do you guys using the FHE to a much more efficient and the right way. Yeah, that's pretty much about the agenda. So I'll just directly get started to my part. So for my part, I choose this name, Ideas on Our Minds. Actually, uh, something on our mind is a series our global events. We do this like ECC on my mind back to January or back to like July this year. And we got a consensus on my mind. We got a Vietnam on my mind. We also got the token 2040 on my mind. So every events we will find a very interesting words to be very represent way to show this. So this topic we would like to tell about the ideas on our mind. So for this kind of presentation, we have three parts. The first part is about the story on our mind. So in this chapter, we will trace back to how we get started to build these projects, what kind of milestone we already achieved, and what's the next chapter we want to achieve in the future. That's first part. And the second part is about what are we building right now. So in this very dynamic market, there are so many noises around the corner. So choose what not to do is much more important than choose to do what. So we also want to share you guys some of the most priority thing we're building right now. The second part. So and the third part is about the future on our mind. So in this chapter, we would like to share more about the future things we want to achieve, for the as well for the BD part, for the product part, or for other kind of existing angle, the things we want to do. That's for our my part agenda today. So yeah, sure, let's get started. The first thing about the story on our mind. So if you heard about my network, so three keywords to remember us is always enough. The first one is called FHE. It's our very deep and fundamental tech, and AI is our client. We also want to co-build more AI like kind of products here. And third is that we also with the slogan of revolutionize the POS validation. The next page, so this page illustrate how do we like find a journey to find a product market fit. So trace back to 2022 December. So that's how we get started. We get the balance incubation, we join the balance incubation program as well as chain link build program. So when we got so many support from them. So after like maybe 3 months later, we successfully win the seed round by Finance Labs, actually, something like that. So they are all very like big backers to support us in the early involving stage. And 1 month later, we want to know what's in this cycle, what is very deep technology we can adapt, we can learn, we can build in a much more longer terminism view. So we finally found FHE. So the product the first prototype we're building is called the FHC data lake. It's a decentralized storage, which like maybe partners can use this to do the data storage with much more encrypted way. So after that, we want to maybe create more underground technology and products. So we co-built the FHC bridge with Chainlink. Later, I will share with this more. And so here comes this year. I mean, the fourth quarter, we generate because risk taking is on the hype on the first quarter. We also get started to think about what risk taking means and how can we do more things with the risk taking this sector by adopting FHC. So we generate the FHC security for all networks through the risk taking. That's pretty about our journey to find our product market fit. So in this page, we want to share what's our fundraising stage. So because I mean, these backers are always the fundamental supporters to mine the network. We also want to show our great thanks operation and appreciation to these backers. So actually, so far we finished our 2 rounds already. The first round we successfully raised 2.5 million, and backed by Binance Snaps and Ethereum Fellow Grant, Chainlink as well as Consensus. 7x comes through the tier 1 VCs, and just one month passed, we get started. I mean, we successfully fundraising another 10 million round. This is the pre-main round. So now at this point, we successfully already finished the fundraising about 12.5 million. It's not a small number, in this cycle. As well, I mean, in all the crypto world. So as long as you get enough money, you got the cash flow to build more interesting things. That's about our cap table. So next page, I want to show more about what is FHE, then help you guys to have a better understanding in a much more easy and understandable way. So FHE, the full name is called the fully homomorphic encryption. It's a little bit hard to pronounce, also very hard to understand. So I want to elaborate in a much more simple way. So let's think imagine a scenario. So in case you are a boy, when you follow up with a girl, so then what you would do? You got 3 plans. So plan A, maybe you will directly say that I love you to the girl. Then the girl will know that you love her truly, and this is a much more straightforward way. Then plan B is that you will prepare a bunch of flowers, just directly send to the girl, but by saying nothing. So this maybe can be a metaphor as that zero knowledge proof ZK. The reason is that you just send the flowers to show you're interested in her, but you didn't directly say that I love you, the words. And when it comes to plan C, so that's how what is about FHG. So maybe you will send them like the code here is the encrypted one. So this is encrypted love. Then you will give the key, private key maybe, to the girls you have a best with. Then after she used the key to unlock that, she will know that you love her. So that's the story of FHG. Hope this can help you guys to easily understand about that. So this is called how do you guys converse or convey the encrypted love. So that's about what it is. So then I want to show you some case study about what we've done in the past 2 years. So one very important case here is that how do we make Chainlink and what kind of products are we building right now. So in this page, divide into 2 parts to illustrate our collaboration. So on the left side is about tech solution framework. Also, it's a little bit complicated. So for the right part, so I just sort out 3 keywords, 3 key lines for you guys to understand. So we co-built the FHG bridge with Chainlink CCIP. The fundamental tech behind that is FHG and CCIP with the following of cross-chain interoperability protocol. So it's a very basic cross-chain interoperability. The ways for you guys to do the message cross-chain or do the smart contract building. And the second part is that we co-built which we call the FH bridge. This helps us to bring traditional finance to Web3. So it also solved the problem because in traditional finance, here are so many very sensitive and very important data you cannot leak to others. But on the blockchain, everything is on the public on chain, so maybe others can trace that on the chain, and this is will very not that good for the institutional users, who we call the smart money, right? The institution money. I mean, this kind of money cannot be traced. So for this reason, so we co-build this bridge with institutional for the clients. We help them to do the data security. So when they're making these transactions, they're holding positions, their like account data, all being encrypted with FHA. This is one of the products we are building right now. So after that, at this moment, I mean, just maybe 2 months before, we get started to think about a new business model, a new products for the mass adoption in this era. Because in crypto, you need to try every means to to embrace your users. Then you will have more consensus, you have more community foundations, you get more words to spread, you get more things to do. So I want to share what I'm building right now here to give you guys another impression. So I am back to uh, April this year, also in Hong Kong. So Vitaly come to Hong Kong to talk about the voting. What he says that voting is the foundation of POS validation. So now have so many ways can be contributional to this scenario. And MPC and FHE is something we cannot ignore. So it's something we need to use. So we mine network. So using FHE to secure the AI and the POS voting consensus. That's our main focus right now. So when it comes to the products, so on the left side, you can see the framework here can be also be split into 3 layers. One is the plugin layer. So back to early stage where you see this to secure the consensus, and on the middle layer is our consensus layer. We got our mine chain, and the bottom layer is our service layer. We want to acquire those climbs in AI, like between the subnet, GPU farms, Eigen AVS, AI agents. We also have some very good innovation here. Got remote staking, we got the consensus security, we got the data protection. Then after we found that, so staking has kind of access problem, as well as the snatch mechanism cannot be that will like known or like being accepted by all the guys. So we pivot to secure the consensus of POS and AI. So for Eigener, Babylon, Symbiotic, they're more focused on the token economy security. But for us, we are very niche on the voting security. So this page, I want to share more what is our new products might be. On the left side is kind of like a very small robots. We got 2 eyes, 1 mouth, and one head. So this is our my use structure. So the structure very simple. We got 2 main important points. So the first point is that we bring the retail users, the risk-taking stakers, the delegation use for their contribution in total governance value providing. And on the right side, we want to bring the use to AI nodes partners, because to provide the voting computing, also secure the voting consensus, so they all will get some earning. So on the right side, it's much more complicated photo. You just need to understand how the users earn their VFHE, delegate their VFHE, and what do we use this to for doing the voting security and voting contribution. So for now, we already like have over 13 billion US dollars, the total governance value from our listing partners. It's not a small amount, as well as we got so many like over 20K users already redeemed the total governance value. So maybe after this week, they're gonna be able to delegate their VFH to our AI contributors. So here lists some of our close risking partners. We got a Bouncebeat on board, we got Etherpay on board, we got Manta, Pencils, Sixstone, Asoph, the BTC pioneers, also Pandos, well, and Renzo. That's for the risk taking part. Then next page, I want to share with you more about the our AI part, our subnets part. So that's our main 2B business model. Is also our ecosystem focus that we can onboard more AI projects to co-build the FHC narrative with us together. So we have two pictures here. On the left side, we got FCN, FDN, and my random gen subnets. These are all like designed or created by ourselves. FCN is the fully consensus network, and FDN is fully like decryption network. We using these two as our basic subnets help us to provide the FHC technology and solutions. And the third one, random gem, is that the first like prototype we use FHC to generate encrypted random number, then sell to other clients who need to use like AI projects need a random number to do the training. I mean, the node partners, they need a random number to empower their hash value when they maybe allocate new voting power and computing power, or like issue new nodes. That's for mind owned subnets we design ourselves. And on the right side is called our partner networks. That's how we onboard our partners to use the FHC to solve their niche problems. So for Lumos and SEO, we will together to generate the FHC encrypted number, then back to their own solutions, because Lumos also need a random number to help them to allocate their kind of computing resources as well for AI. So we also have so many like BD partners on the pipeline. Our name 0G KIP, Infostone as well thing, Carve for game sector, and the Rivals for AI rollups. So we got more coming soon. So just looking forward to that. So we already talked to you so much about this very long and complicated process. So in this page, I want to share more about like simple ways. So how can we, like as a user, how do you get started? What kind of things can we do right now? So it's very simple user journey. As long as the stakers stake any assets on our partnership projects, you can just directly jump to our website to redeem the VFHG. That means you are the vote holders. Then after 1 week, as I mentioned before, you can delegate your VFH token to voter, as well. We call that AI nodes. So actually, these the voters here to earn more VFH. Then you can trace back to again. So this is over and over repeating process you can do anytime. Then the noders, the voters will help to provide the average validation as well as voting security consensus for our AI partners. That's the user journey. And then on the right side, so our content team, thanks to our content team, generate this very interesting and cute Mimi token here. So 6 keywords here. As long as, because as a user you provide the assets, you have the assets ownership, then you should have the governance rights. So we will airdrop those governance rights to you guys by the FHE way, VFHE way. That's how you earn VFHE, by holding LST and ART like Puffetage or Stone or others. So you provide a total governance value, then you get a token. The governance token we airdrop to you guys. Then you can use this to delegate to back to the process again. So that's how we bring you guys to the moon through the simple journey. Okay, thanks. Then this at this page, also we want to show the data and the research output we're doing right now, because we call us like more research and tech-driven team. So we get so many research papers already like issued or released with Ethereum Foundation, and that's for the research work. And also, on our testnet, on our products, we're also doing so many attractions and adoptions. Right now, we have over 650 K wallets back to testnet stage, got over 3.2 million transactions. And for now, after we're launching our new products, so the new organic data also shows very good. So we just waiting for the time to have a more round of booming out. So for the future, our in the last maybe 10 minutes, I share about what's the past what we've done. So I also want to share some new things, the future on our mind. So on the left side, we got so many solutions with leading partners. We'll like will like also stay on the stage, try to onboard as much as possible. So in the overall structure, we got so many good numbers, so many good data can let everybody know. So we get billions of tokenized voting TVO and contributors. We will have hundreds, thousands of voters and nodes. Also, we got so many solid air projects will join the whole ecosystem. Yeah, so that's pretty much about what I want to share with you guys. Cheers for the futures on our mind. That's all from my side. Thanks. Let's invite our CSO, Chief Security Officer, Dennis, to continue this presentation. Thank you so much.
Yeah, thank you, Liang. And I will share my screen. Wait a minute.
Cool.
Let me check share screen.
Yeah, you just tap the present button. And yeah, share screen.
Yeah, window sharing. And okay. Entire screen. Yeah, I got this one. Okay. Can you see my screen? Yeah, it's there.
Yeah, can.
Okay. Yeah. Hi, everyone. My name is Dennis, and I'm the co-founder of my network, and I'm also the chief security officer. As Leon just mentioned, our Mind V has two parts. One is the restaking part, and the other is the very complicated voting part. And today I will dive into the complicated one, the voting part, and introduce the techniques involved in this part. And it's actually a voting network empowered by FHE. And I will introduce the principles and the design of the our Mind V subnets. And yeah, voting is very important. No need to say too much about this, because next week there will be the one of the most important election in the world. Is the election of the United States, and actually the whole world had been already focused on it for maybe at least for a whole year. So voting is very important in human society. And also, voting is important in technology. You have already been very familiar with the DAO, the Decentralized Autonomous Organizations. On the blockchain, we often use this for governance. We use that to decide the parameters of the protocol, or maybe to distribute to the distribution plans of the rewards. We use DAO a lot to be more fair, to decide that kind of the parameters. And that's actually the voting scenario which human is involved. Actually, there is also some automation process which do not require human involved. For example, on blockchain, when we need to get consensus, or actually when we need to get consensus, we need to some kind of the election of the blocks, or maybe the validators. In that kind of the election, voting is also involved. So voting is also very important in technology. Yeah, and speaking of the voting, especially the traditional voting, what's the drawback of this one? Actually, I think one of the most significant one is it's about trust. We have to trust someone throughout this voting procedure. Usually in the traditional voting scenario, there will be some authority, for example, the voting committee. So we need to trust that this committee did do everything correctly. We trust that the committee collect the votes correctly, compute the votes correctly, and produce a correct result. So, so we need to trust this. Actually, this one. This is the boss. Everyone send their votes to this authority, and this can be this vote can be keep privacy, can be anonymous, and no one knows each other's votes. But this authority, he will count the votes, so he knows everything. He will read the votes and then do the computation, generate the final result of the voting. So this is the traditional scenario. However, there may be sometimes there will be some problem with this scenario because this authority is not always trustworthy. Sometimes in some cases, this authority will do something bad. It will maybe manipulate the votes or manipulate the result. And in these scenarios, the voting is not trustworthy for the complete voting mechanism. So what we can do to improve this? We can first see what's the most important principles for a fair voting mechanism. We think that these three principles are the most important one. One is transparency and accountability, accountability and privacy. Let's have a look at the first one, the transparency. Transparency is very important to get the trust because, for example, in the traditional scenario, if the operation of the voting committee is not very transparent, then the voters will doubt the result. So transparency is very important. However, in the traditional scenario, it's very hard to achieve the complete transparency because for the committee, they have to do something. For example, do the computation on their own side, and they can and others cannot just monitor the whole process from end to end. Luckily, we nowadays we have some modern technologies, especially the blockchain. Blockchain is very good for the transparency because blockchain is actually completely open to the public. Anyone can read the information on the blockchain, and the information is not mutable. So anyone who doubts about the result, he can just audit the result at any time. So that's a very good benefit brought by the blockchain. So in our design, we just involved a chain which is called miner chain. This miner chain is nothing different, but it's actually nothing special. It's a normal EVM chain. It's dedicated for the purpose of voting, our complete voting, for example, contracts and other mechanism are deployed on this miner chain. So for the first part, we have the transparency. And transparency is transparency it alone is not enough because if the voting scenario is completely not related to me, I will just give a random vote because it's none of my business. I just generate a random vote, and I do not take any responsibility for this vote. And also, lucky enough, we can solve this problem just with the smart contract, because if the voting is related, it's related to each voter's benefits, they will just take fully responsibility. They will take the responsibility for themselves. They will just give out a responsible vote to the system. So we use the smart contract to do the parts of the incentive distribution or the penalties. Then the voters, since they are driven by the interest, they will just generate the responsible vote for themselves. So we deployed several contracts on the mine chain, which is dedicated for the reward distribution. Actually, in mine chain we have a token which is called VFHE. It's actually for the purpose of voting, and that token is distributed by this contract to make sure that each voter is responsible for their own votes. With this transparency and accountability, we have many successful cases. For example, the DAO. I just introduced that before. We can just vote, give the responsible vote, and get the rewards from a DAO system. And there's also a very successful AI project called BitTensor. It also uses this voting mechanism. It's used the blockchain to make it transparent, and it distributes token of TAO to their participants, so that they can do the contribution to the AI networks. That's what BitTensor do, and they works very well. However, DAO and BitTensor, they are not perfect. Because they have already solved the transparency and accountability problem, and there's still something left. Because since the voters, they are driven by their by interest, they have the motivation to cheat in this process. For example, in BitTensor, you can just take the follow strategy. You can, from the blockchain, you can find someone who is a big whale, and you can just vote following him. Because the big whale, they just take a large part of their voting weights, and the final result would be close to his vote. And if you follow the big whales, you will get your best benefit, your biggest interest. So that's kind of the cheating scenario. To mitigate this kind of the cheating, the copying strategy, we have to involve the privacy. What we want is that in the whole process, the voters, they are not able to see each other's votes. It's actually not actually a problem in the traditional voting scenario, because the voters, they just vote and they do not see each other's vote. However, on blockchain, that will be a problem, because as I mentioned before, on blockchain, it's actually open to everyone. Everyone can see others' votes, because we cannot make sure that everyone vote concurrently in the exact same block. That's not possible in the real world. So there will be someone who votes in advance and some votes later. And the later voters, they will be able to see the votes of others. And that's not fair. They can just copy and follow others, follow someone's vote and get their own benefit. To achieve this purpose for privacy, we can use encryption. We can encrypt the vote of each voters, and we will get the privacy. So in our design, we used the framework of Zama. We used the TF-HEI's framework to encrypt the data, and so that each voter won't be able to see each other's results. And we wrapped that and developed our own subnet SDK. That's the encrypt part of our MindV subnets. However, there brings another problem, because privacy and transparency, they somehow contradict each other. We cannot get the complete privacy and the complete transparency at the same time. If we encrypt the data, and that means there's no transparency, because the voters, they won't be able to see each other's vote. Then we have to make a choice, or we can find some balance between that. In the traditional scenario, every vote, they send out an anonymous vote, and they won't be able to see each other's vote. However, this authority can. So he can just compute and generate a final result. However, in the blockchain scenario, in DAO or in BitTensor, everyone, they send out the vote to the blockchain, but this will be completed in plain text. Everyone can see each other's vote, and the blockchain, they will compute the vote and generate a final result. So that brings that brings this cheating problem. They can copy each other, and somehow we can just get a balance between this privacy and transparency. These two dimensions. Maybe we can achieve some delayed transparency to get rid of the both of the problem, because if we just disclose the computation result just after the reward distribution, actually we can just first generate the voting result, and we just distribute the rewards. After that, after the computation, we can disclose each voter's votes. That's called delayed transparency, because the transparency happens after the voting results. At that scenario, the voters, they won't be able to copy each other's vote, because before the final result, they are completely they can vote with their privacy. They do not each other's. However, after the final result, there will be the complete transparency. That solves the whole problem. So we just make the results visible only after the votes are counted and the rewards are calculated. But how can we do that? That involves a technology called privacy computing. Actually, to be more definition, to be more precisely, we are using the privacy computing technology, which is called fully homomorphic encryption, FHE, to secure the process. So we have this FCN and FDN part and the voting nodes. We just calculate the voting results in these parts, and then we will disclose and send the plain text to the blockchain. So that's called the delayed transparency. This is the process of the delayed transparency. Actually, each voter, they send out their votes. However, the vote is encrypted by the FHE public key. So the result won't be decrypted by any of these voters. The private key is only mastered by this network called FDN. It's FHE decryption network, and so at the left part, the complete left part, they won't be aware of anything about the voting information. So that's the benefit of FHE. FHE, by using FHE, it can be, the result can be calculated, can be computed over the ciphertext. This means each voters, they send the ciphertext to the FCN. FCN is FHE consensus network. It just take the responsibility of the computation process. Each voter send the ciphertext to the FCN. FCN, it is capable of calculating the results over the ciphertext. It does not require the private key. So the FCN do not decrypt the ciphertext. It just compute over the ciphertext and then generate encrypted result. The result is also encrypted, and it can also be decrypted with the private key, which is mastered by the FDN. So at this step, the result is consensus. So the generated result is on the blockchain. However, it's in ciphertext, it's encrypted. And then the FDN, it is capable of decrypting this final result. It's just decrypt and disclose the result of the voting. If anyone has questions, they doubt about the result, FDN is also capable of decrypting the result of each voters. And then it can also disclose each votes. So it can prove to everyone that the complete process is fair and the vote is processed correctly. Because anyone, they have questions, they have doubts, they can just compute over this plain text and check whether the final result is correct. So that's the privacy computing part. We used the fully homomorphic encryption. And we also want flexibility. Besides that, the triangle, the three parts, besides the transparency, accountability, and privacy, we also want the flexibility, because we do not want this such complicated voting network is dedicated for a single purpose. We want this to be able to adapt to different voting scenarios. So we developed this framework here, and actually every developers will be able to write their own subnet above our voting network. We will actually open source the SDK, and every developers can call that kind of SDK and build their own contract, deploy on the main chain, so that they will be able to write their own subnets to solve different problems. So at this stage, the complete architect of our MindV subnet is here. Yeah, this is the complete part of the MindV subnet. At the bottom is actually the infrastructure part. We have the miner chain. We have numerous voting nodes. Actually, anyone is able to set up their own voting nodes and join the network to get the benefits, to get the incentive from the voting network. And we have also in the infra layer, we also have the Zama framework, which is used to handle the encryption part, the Zama TFHEIS framework. And in the above layer, we have the controller, subnet controller. Its purpose is to coordinate between the subnets, because the subnets they were used to they actually call each other. They can consume each other's result output. For example, this FCN, FDN, they are also some kind of the subnet, and the subnet, for example, we have the prototype, the very first subnet called Ranjin. Each of this application subnet will need to call the FCN, call the FDN to handle the FHE computation process. And the controller's purpose is to coordinate the subnets, and it also controls the reward distribution between the different subnets. And in this layer, we have the contract for different subnets. And also in the top layer, it's actually the application layer, and any developers is able to develop their own subnet by using the SDK, and by calling this FCN and FDN part. FCN, again, I will tell you more about the FCN and FDN. Actually, FCN is FHE consensus network. It handles the FHE computing part. It is capable of doing the computation over the ciphertext. And FDN is FHE decryption network. It is able to decrypt the ciphertext, which is generated from the voters or the voting nodes, and also the results generated by FCN, because the result generated by FCN is also an encrypted result, and it requires the FDN to encrypt this to decrypt this kind of the result. Yeah, and that's the okay. I will talk more about the application layers. At the top layer is the application layer, and anyone can generate any developer they actually can write some kind of their subnets for different voting scenarios. Currently, we have a very first and very simple use case. It's called Ranjin. It's for random number generation. In the tech world, random number is very important. Actually, for example, when we generate some account, we will generate the private key. In the process of the key generation, it requires a random number. If the number is predictable and your private key will be predictable, that's very dangerous scenario, because your private key will be able to be guessed by others. So in this kind, the random number is very important. It's for the security and the cryptography purpose. And also in some gaming, for example, in GameFi or in some NFT game, when we need to open the treasure box, the treasure chest, yeah, it also heavily relies on the random number, because there will be the drop rate of the treasure box. Sometimes you get a very, very valuable turnout, and something you get nothing. That's all determined by the random number. If the process is not well designed, and the participants will doubt why I get nothing, and why did he get a very valuable NFT? So you have to explain. You need to explain the random number to the participants. In traditional scenario, we just generate the random number in a single machine. That's not very convincing. It's actually that anyone can doubt whether the random number is truly random, or maybe you just manipulate the random number to get the turnout to be more benefit for yourself. So any participants can doubt about that. However, if we use this RandGen subnet, the random number generation is actually generated by the complete voting network. Any voters in the network, they just contribute to the random number, as long as not all of the voters are malicious. This random number generation can be trust, because the randomness is contributed by anyone, and anyone they can just contribute to the random and make sure the random number is not predictable. In the whole process, the meaning of encryption is that if the voters, they do not know the final result, they are not able to manipulate their own contributed randomness to manipulate the final results. So that's completely blind for each voters, and they just can send their own randomness to their network, and the RandGen subnet will generate a random number. So that number would be completely random, and you can trust it because that's contributed by the whole network. As long as not all of them are malicious, this random number is truly random. So that's the purpose of the RandGen subnet, and that's also a very, very simple use case. And we will also develop more subnets, and we also encourage developers to contribute to develop more subnets. So we, but frankly speaking, currently the application layer, the development of the application layer is still maybe a bit complicated. So we are still working to simplify this process of developing the application subnet. We will do some modularization at this interface. We will modularize them, and so that the subnet developers can just use some of the wrapped up module to simplify their developing process. Currently, as our expectation, as our estimation, the development of an application subnet would maybe involve the developer a period of around 1 month. So we think that might be still too complicated for an hackathon. So currently we just went for an ideathon. So the developers do not have to develop the complete subnet. They can just come up with some ideas and design the subnet instead of the implementation, because we are still simplify this SDK and interface, and during this process, maybe the developers can use some more easy use modules, and they can develop the subnets more easily. At that time, we can just run a hackathon and do the complete subnet development. So at the current stage, we will just encourage ideas of the design, and then then next for the implementation. Yeah, that's it for my tech part of the sharing. And thank you for everyone. Actually, you can just participate to this idea zone by joining the DoraHacks, by viewing the DoraHacks link, and you will get the information on that on the event page. Yeah, thank you. Thank you for everyone. Thank you everyone for the attending.
Okay, cool. Thank you, guys. So any questions, feel free to reach us through Twitter or through DoraHacks. Thanks. So Lini, I think we are all good here. Hello, Lini, are you still there? Or... Okay, thank you so much, Crypto Nick. Yeah, hope can see you guys soon. Okay, bye-bye. Bye-bye.
Bye-bye.